Next up, please welcome Liquidity Nanotech. Presenting is Victor Hwang.
Hi, my name is Victor Hwang. I'm the CEO of Liquidity. We design products that make water safe to drink, instantly, anytime, anywhere. To explain, let me introduce you to someone. This is E. coli. He's a nasty-looking creature. And if you drink him, he's even nastier. And it's not just E. coli. He's got a bunch of nasty buddies like Cryptosporidium and Giardia. Every day, they get millions of people sick. 10,000 people will die today because of these guys. 1 billion people on the planet cannot get dependably safe drinking water because of them. Now, why is this so hard? So here's a number to remember. 6 nines, 99.9999%. This is a commonly accepted standard for bacteria reduction in order to get safe drinking water. It's what the EPA uses. But this is a very hard standard because it means that fewer than 1 out of a million bacteria can make it from the source of the water to your lips in order for you to stay safe. This is compounded in difficulty by the fact that you can't see this stuff. These germs are not visible to the naked eye. It's the invisible stuff that kills you. You can't just take water that looks dirty and make it clear in order to be safe. Until now, the world has had to make a fundamental trade-off. On one hand, you had products that didn't work, and on the other hand, you had products that were really hard to use. So common household products that use activated carbon, they don't get rid of the germs that actually harm you. Other methods like UV lights, pressurized systems, or chemicals like chlorine or iodine, they've got all sorts of drawbacks. They take electricity, they require pumping or sucking, they take a lot of time, or they don't taste very good. Liquidity's technology transcends the state of the art. We are able to eliminate those trade-offs. For the first time, you can get instantly safe drinking water with no chemicals, no electricity, and no pumping. Now, why is this important? Well, it means that we can combine effectiveness, remember, 99.9999%, with convenience, something that's hassle-free, to create everyday use products. This is a huge deal because it means that we can finally take water from being a scarce and precious resource and make it into something that's ordinary and commonplace and universal. So we have the TechCrunch staff that was very kind to go up to Central Park just a couple hours ago and get water fresh from the source. This is New York's finest. And I want to do a demonstration just to show you just how easy this is to use. Thank you, guys. This is what we've got here. And you can see in this bottle, this is a bottle using our technology, just how fast the water flows. Just like that. It's nearly effortless. It's like drinking from a normal sports water bottle. In fact, it's so easy to use, my 6-year-old loves drinking from this. So how does this work? Well, geek out with me for just a little bit as I explain. So we're able to create a dense web of fibers that are amazingly thin. They're 1/600th the width of a human hair. We can take these fibers and put them into a membrane, and then put that membrane into a cartridge, just like this one, which is what I just used in the bottle I just drank from. The way we make this is like a form of extreme 3D printing. We have hundreds of nozzles spinning down these fibers at the speed of sound. It's an amazingly precise, environmentally controlled process with scientific precision. You can think of it as mass production meets 3D printing on steroids. And when these fibers are deposited down, you get this, which is this dense mesh of fibers. And this is a cross-section view. You can see as the particles travel from the top to the bottom in this picture, the bacteria get stuck at the top. They can't make it through. They get stuck like fish trying to get through a fish net. So the bacteria stop, but the water flows. In fact, the water flows ridiculously fast. To bring this idea to life, we had to put together a dream team of some of the leading scientists, engineers, business people, and experts in the world in clean drinking water. These are veterans of some of the leading brands in the business. In fact, every single day, you probably drink water that was filtered by products that our team helped develop. And there's serious science here. There's over 15 years of fundamental R&D from Stony Brook University, supported by the National Science Foundation. And boy, have we tested this. We've done countless tests. In fact, we've published a test report on our website from a respected, independent, third-party laboratory. We're rolling out several different products. The first product is this. This is our personal water bottle. We call it Naked Filter. It allows you to get instantly safe drinking water anytime. We're selling this all over the world. Next, we're going to roll out to a number of other products, including household products, like this one here, where you put dirty water in the top and get clean drinking water out below. And then industrial and commercial applications, like biomedical processing and other sectors. Our plan is to become an Intel Inside that powers an entire generation of new products in the water industry. We're going to roll this out all over the world, but we're going to do it in key stages. So we've already started in the United States and Europe, where we're reaching out to the health and the wellness and the recreational markets. These are the same people that buy from Whole Foods or REI. But there's a huge opportunity where we're simultaneously going after, which is the growing middle classes in the emerging markets, places like Brazil, China, India, Mexico. There are hundreds of millions of people with purchasing power, but still cannot get dependably safe drinking water. So a mother in Sao Paulo who is concerned about her child's health can take this water bottle and put it in their backpack when they go to school in the morning and be guaranteed that they're getting safe drinking water all day long. Once we scale up and are able to reduce manufacturing costs, our plan is to take this everywhere else. Bottom of the pyramid, rural villages. Our vision is to reach 1 billion people. We're really excited here at TechCrunch Disrupt to announce that you can now purchase our Naked Filter water bottle directly off of our website, nakedfilter.com. You can go there and pre-order one right now, and we're going to ship them in 3 months. In fact, I encourage you to do so because you'll be getting healthier water for yourself, but you'll also be joining us on a journey as we bring cleaner, safer drinking water to everybody on the planet. Thank you very much.
All right.
So, this is awesome. Can you talk to us about cost and how long does the filter last for? How often do I need to replace it? Cost per unit for the filter?
Sure. Retail price right now, we're selling this on our website right now, $24 for a full unit. You can buy replacement cartridges for $8 each if you buy them in a pack of 3. Depending on the water quality varies dramatically from place to place. So one cartridge like this should last in normally challenging water for anywhere from 1 month to 3 months, depending on where you are. In the United States, we use these, and these last for 2 to 3 months without a problem. In places where it's really dirty water, then it's going to last shorter, but it's going to vary.
And talk about your competition a little bit, because there are the people out there who are building products like this. And so why is this, how is this fundamentally better, fundamentally different than what else is out there?
Yeah. Well, this is the only technology that uses mechanical filtration, where it's actually catching things like fish going through a fish net at this level of filtration with this kind of flow rate. So their competition, they will find, if you look at traditional membranes, for instance, they tend to have a lot more solid area, so you can't get that fast flow rate. You can't just squeeze it out of a water bottle. You have to pump it, right? Or you have to suck it from a straw. The lung power you have to use can be significant. There's UV lights where you have to wait, time, and it doesn't get rid of everything. There's tablets people can use where you have to wait, 30 to 60 minutes in order to get safe drinking water, and then it doesn't taste good and it's bad for your health over the long term. So there's a variety of different competitors, and we realize it's a competitive market space. So one of the challenges is going to be, getting the message out cleanly and precisely to the consumers.
Are you going to? So you talked, I think, about an OEM business model where your cartridges will end up in somebody else's product potentially. Are you also building a brand? Is this a consumer product, or has nothing to do with a consumer product?
Yeah, we're going to pursue both strategies right now because we want to reach out with our own brand to start building a consumer base and getting people to adopt it and start to use it. But there's a huge opportunity in developing OEM products to everybody else, and we're going to pursue that simultaneously.
How do you know when a filter's used up, and how foolproof is that, and are there any dangers if you use a filter for too long?
One of the great things about this is it's good to the last drop. Actually, every single drop coming out of that is guaranteed to filter the germs. And as it gets used up, it just slows down. And when it slows down enough and consumer says it's not satisfactory, just swap out another cartridge.
How does that work? How do you control the flow based upon how dirty it's gotten?
Yeah, as it plugs up, it just plugs up the surface or the holes. And so once it gets used up, nothing else can get through.
Can we see one of the filters?
Yeah, sure. This is a prototype.
Try
so
the water?
not full production units.
Some fresh, clean water you guys could drink if you want. Say.
Brian, you're from California.
I'm scared.
Membrane technology to filter water is not new. Technically, how does your membrane work, or what does it do that's new?
Yeah, membranes, this is a major fundamental shift in membranes over the last half century. In fact, if you look at the membranes people use today, they haven't changed that much in many decades. They are mostly solid material with holes in them. So about 20% holes, 80% solid material. And the holes are smaller than the bacteria. we changed the paradigm by creating this mesh-like structure. We're able to actually flip it. So we're instead of 20% air, we're getting 80% air and 20% solid material, like a fishnet. So we're able to get very high flow rates while we're getting that same level of effective filtration. So that's really the big difference.
And in the developing markets, why not just use a chlorine tablet? It seems a lot less expensive than a $24 water bottle.
Chlorine's cheap, but chlorine, if you've ever been camping, or iodine, it takes time. You put it in there, you got to wait for a while, and then a lot of people have dechlorinators or de-iodine. They're iodine removers because iodine doesn't taste very good. Again, it's about convenience, something that allows people to use it every day. You wouldn't expect your kids to do chlorine tablets every day at school. That's really what we're targeting.
How large is the recreational market in the U.S. for this type of product?
Well, it's the Whole Foods market. So the people, Whole Foods and REI. So the people that care about their health, they're athletes, they're people that care about, they eat organic and natural foods, the people that are concerned about contamination, people who are in hospitals, who are ill, maybe who are at risk of disease. So we're really looking at those types of people that are extremely health conscious. For a specific number, I don't have it off the top of my head, but it's a big market.
Where do you focus on the market right now? Is it on that, or developing countries, or OEM deals? I mean, I know you mentioned both, but what's your gut on where you'd spend your time?
The gut is we will be able to build some traction with our brand in the U.S., but we just launched this very recently, just weeks ago, and we're getting requests in the millions of units from emerging markets already. I mean, the demand is enormous. So my guess is that the world where people, especially where people can't count on their drinking water, when they turn on a tap, that's where the market's going to be the biggest.
What is your cost per unit?
They're pretty good. They're very robust. They're very competitive with the industry. I don't want to, we're able to make this, especially as we get to scale, where we can drive down the costs and be able to sell this pretty competitively with anything else that's out there.
Can I try your water?
Sure.
Oh.
Brave.
Woo!
I'm going to ask the same question a different way. I mean, can you speak to the gross margin of that $8? I'm paying $8 per filter. What's the...
Well, I will say the industry...
How is
You know what? I'll try it as well.
rating.
It's the only cup I have, so...
Oh.
Okay, we're all friends.
You want
here.
to use the same cup?
Yeah, I don't mind, actually.
All right.
I'll take next.
If I'm going to drink the water.
We're thirsty. California.
The industry primarily operates at margins.
Oh, he's got another
you get
cup.
more cups. Oh, thank you. We'll give her a fresh cup. You don't want to get germs.
I'm not concerned about the cup. The cup isn't my main concern. Sorry.
The industry primarily operates in margins of,
Thank you.
50, 60, 70%. If you go to the biomedical industry, we're talking 80, 90% margins. Those are typical filter industry margins that justify the operations that they have.
Well, how will you distribute on scale? And are you at first going to be relying on other people's brands in selling it, or will you have your own distribution strategy?
We're going to work a lot with partners. So there's a lot of companies, especially in markets where we just don't know, where they have established brands for distribution. They have consumer product brands that are out there. So we're already working with a number of them, and we're going to plan on working with a lot more. Just for some perspective, for years this was a science and engineering company, and it took that long, and it's taken that much effort to get this product ready. So right now we're transitioning to becoming a consumer marketing company, and we have to actually build out that whole part of the company. We don't really have it right now. So this is really the next phase of the company's development.
How long have you been working on this?
The professors worked on it for over 15 years. I met the professors over 9 years ago. So I've been working on this quite a long time. And it's gone through a number of iterations. The company, as it currently exists, actually started 5 years ago. And then we've been developing, getting this right. I mean, it seems simple in concept, but this is so hard to do, ridiculously hard to do.
Can you talk a little bit about how you're going to build trust in the system? Because at least in the developing world, filters were used to improve the flavor of water, but actually trusting that this is going to filter. There's something I think psychologically very different about throwing a chlorine pill into some water, and then and drinking from that, even if it doesn't taste good, versus drinking from where you see the source, right? I mean, it's a very, very different way of dealing with the problem, and you're going to have to build trust.
Yeah.
How do you think about that?
I think that is a key challenge. I'd say the biggest obstacle we faced as a company, really, has been disbelief. People don't believe it's possible because they're so used to water as being this really hard, precious thing.
Yeah.
And the idea that you can suddenly just make it just like that, that's safe to drink. A lot of people have a hard time with that because it doesn't fit anything they've known their entire lives. So being able to work with partners and brands and people that know how to bring out products that people can trust, that's really key for us going forward.
Are there chemical and environmental toxins that you can't filter out?
This is focused on the stuff that harms you the fastest, the bacteria and the protozoa. So we don't go after chemicals. There are some methods that one can do that already that exist on the market, and potentially those could be added in future versions of this, but we're going after the stuff that is the most harmful right away.
I just was going to make sure that you're a for-profit company.
Yeah, it's a for-profit company.
Okay.
Yeah.
And will you have a program when you distribute it to poor nations, developed countries, where you'll maybe give one for each one that you sell? Do you have any notion of doing some social activity besides selling it?
Yeah, we've actually been thinking a lot about doing something like that. So welcome any ideas on that.
Very quickly, I've been wondering this, both presentations. Is there any possibility of ingesting the little fibers? And if so, is there any risk to the person doing that?
Yeah, the fibers don't come off. They're so long. They just don't stop. They run for kilometers and kilometers. So they're firmly wedged into the membrane.
Awesome. All right. Well, we're out of time. Super cool. That was Liquidity Nanotech. Thank you very much. All right.